Good afternoon, everyone. This is Jan. I'm the head of the Global Partnership at the Cold Chain Innovation Hub, and I'm very happy to welcome you all to our Contributors Session number 2, a webinar under the project that serves to introduce the contributors and to discuss the technologies that are being provided to the Cold Chain Innovation Hub and how they fit to the food cold chain sector in Philippines. So I'm very happy to be here with you today with my colleagues. I will be co-chairing this webinar together with my colleague Devin Yoshimoto and our colleagues in Philippines. So welcome again to all of you to our following contributor session. A short agenda in the very beginning. So we will spend about 10 minutes on a short introduction. We will then spend the major part of the webinar, of course, roughly 90 minutes working with the contributors. So we have 5 contributions today to discuss about. We will have leading presenters from several companies that we will introduce shortly. There will be plenty of time for questions and answers from our panelists, but also, if we have any comments, additional contributions for the discussion from the panelists and the speakers, as well as the attendees, please do send us messages, and you can also join us live. Finally, we will have a closing Q&A session for about 20 minutes, so we estimate about 2 hours dedicated for this webinar. First of all, I would like us to, I would like you to join me with applause and big thanks to all our contributors. So we have introduced a number of them in our first webinar on 27th of September. I would like to say again, thank you to AHT, a member of Daikin Group. Thank you to Kerry Transicold, Central Group, Cold Front, newly Danish Technological Institute, Embraconidec, EPTA, Future Green Now, Panasonic, Hussmann, Product Blocks, Next Electronics, and also newly joining Westfrost. So you might have noticed that we have a number of new contributors, and we are happy that we will hear from some of them today as well. So who will be our contributors today? We will first hear a message from Kerry Transicold. Kerry Transicold has provided the CO2 reefer, the natural line, and we will hear from Mr. Suresh. Unfortunately, he is not able to join us live as he's located in the US, and the time zone is simply prohibiting us to have this live interaction at this point. So we have pre-recorded the video, and we will be starting with this contribution at the very beginning of the webinar. Our next contributor presenter will be Wynand from Future Green Now, a true expert when it comes to natural refrigerants and CO2. And I believe many of you are quite familiar with him already. I'm also pleased to introduce and work with our speakers from Panasonic and Hussmann. We know that Panasonic and Hussmann are one group. We will hear from 2 of the industry experts from Panasonic and Hussmann, and we will be discussing about their CO2 solutions at today's webinar. So many thanks to Panasonic and Hussmann as well. And as mentioned before, we will have plentiful opportunities for discussions and questions. So please submit them in the chat that you can see available here at the Zoom. With that, I would like to also welcome you or invite you to see the contributors website on our project website, where you can see all the contributors as well as the technologies that have been provided. We are very excited to show you today also a fairly exclusive video rendering of the hub and the vision that we are working on now to realize this facility with state-of-the-art technologies using natural refrigerants. So we'll be playing the video shortly. Before I hand over to my colleague Devin Yoshimoto, I would like to also inform everyone and to introduce and welcome our new colleague, Mr. Manuel Azuena. He's newly joined in October as a National Project Coordinator at the Cold Chain Innovation Hub. Manuel, Manny, as we like to call him, is very well known to the industry. He's a true expert and advocate of natural refrigerants, so we're very happy and humbled to have the opportunity to have him in our team. And again, we look forward to all the interactions. Hello, Mani, welcome. Please say a few words. Again, you are very well known in the industry, but I'm sure this is going to be very positive news for everyone.
Hello, Jan. Hello, Devin. First of all, I would like to thank Jan and Devin for making me a member of the CCI-Hub in the Philippines. So I'm now a team player. And of course, I would like to thank the contributors in making this CCI-Hub in the Philippines a reality. You know, your contributions will be a part of a great event in the history of the Philippine CCI, you know, the commercial refrigeration. And I look forward to somewhat working with you all on the CCI-Hub, maybe especially once we have launched and start the final implementation of the CCI-Hub in the Philippines, hopefully by next year. So I would like to thank also TESDA and other stakeholders for this opportunity to be part of the CCI-Hub. Thank you very much. Thank you.
Thank you as well, Mani, and please stay with us for the duration of the webinar. I'm sure you will have questions, and you can also perhaps help answer some of the questions from the audience. So thank you very much, and with that, again, welcome to our team, and I will hand over to my colleague Devin Yoshimoto.
Okay, hello everybody. Hello again to everybody who's joining us today for our second contributors session, where we're going to be having our speakers joining us for a presentation in just a few minutes. But as I'd like to do for people who might be joining us for the first time, I'm going to go over a really quick overview of the planned CCI-Hub facility, where we're really excited because we're making some real progress today, especially with the help of Manuel and our friends and partners over at TESDA, who are currently undertaking the preparations of the facility. And we're really getting excited because things are starting to become real. And we have a 3D rendered video that we released recently to the group, and I'm going to show it really quickly at the end of these few slides here. We'll do a quick overview. TESDA is the Technical Education and Skills Development of the Philippines, and it's the official government agency tasked with the skills development of the Filipino workforce. So really great partner to have with us to help scale up this training of these new technologies and how to handle them safely and professionally. And with the help of all our partners at TESDA, we can help make that happen. The TESDA Regional Training Center in the National Capital Region, the RTC NCR in Manila, is only a short distance from the airport and also from the Port of Manila. So it's a great location for the CCI-Hub facility because it's central to connect all our partners, both internationally as well as in the Metro Manila region. So really quickly, here is a bird's eye view of the campus. You can see on the left-hand corner, top left-hand corner, we have the section, the building where the CCI-Hub facility will be located. This is what it looks like from the side, and that part that was highlighted is on the right. We've done some renderings in the past just to give you an idea of what this could look like. We want to highlight that the focus of this facility will be to showcase these new technologies for the food cold chain and to showcase and educate the general public and all key stakeholders on the value of these sustainable and energy efficient technologies that range from all the way from the farm to the fork. So everyone from rural agriculture to transport, retail, logistics. And we want this to be an ecosystem of technical resources, knowledge sharing and collaboration, and especially with our contributing partners. So just a really quick breakdown of some of the floor plan layouts, the ideas that we've come up with so far. Of course, this is subject to change, but this is what we've been thinking. We're going to have a cold storage room with live running systems, testing medium temperatures, low temperatures for food storage. We'll also have a separate training room where we'll be displaying other types of systems for retail, commercial retail refrigeration, like display cabinets, plug-in systems, all running off natural refrigerants. We'll do trainings and demonstrations. In the workshop in the exhibition area, which is the bigger room, we're going to do a showcase and more of an exhibition of all these technologies. They won't be running live maybe, but we'll be able to show a lot more variety, do a lot more education. And we'll also have everything from printed materials, interactive media. We want to have training materials for natural refrigerants, how to handle high pressures, flammability, and toxicity, as well as general safety, installation, maintenance, and operation with the help of our experts. So let me just really quickly show this video that we've been lucky enough to receive from our partners at Testa, who created this really recently. And it's really a great video, we think, showcasing the future vision that we have for this space. So let me just talk through it. There's no audio, but this is just a rendering of the exhibition area that I spoke about earlier, where we can have different types of technologies, from condensing units all the way to larger rack systems, even all the components and the smaller parts of the systems we can highlight and focus on, really using this space to educate and to train the technicians, the general public, the end users, everyone who's interested in developing these technologies for the Philippines, and educating them on how these technologies specifically contribute to sustainability, reducing emissions, and operating operating with high energy efficiency. So eliminating emissions not only through direct emissions of refrigerants, things like that, but also through maximizing energy efficiency and reducing indirect emissions generated from non-renewable energy sources. So you can see here, this is the first floor. We plan to have different areas focused on different things. We hope to have rooms that will be focused on both training on the technologies, but also lecture style classes and things where we're speaking more of like an academic format. Then we also have a second floor here. I'll just move along really quick. And here, it's nice because we have sort of a bird's eye view of the exhibition floor from the second floor, which is really exciting and interesting for us as well, we thought. And yeah, just on the second floor here, we have a little area where it's sort of a combined lecture and a component exhibition area. So yeah, it's really great that we had our friends at Testa put this together. So we're really thankful for that. But yeah, let me just hand it over back to Jan now to introduce our first speaker. Actually, no, here's Jan's contact information. So please get in touch with Jan. I'm going to go ahead and play our recorded interview from Carrier Transicold, Suresh Duresamy, who joined us for our training, our transport webinar that we held recently, who will be speaking about Carrier Transicold's donation or contribution of CO2 natural line refrigerated container. And he speaks about a lot of interesting things about the container and sort of gives some background on Carrier's vision for using CO2 technologies. So let me share my screen here, and then I'll let Suresh take it away.
Hello, good day, everyone. This is Suresh Duresamy from Carrier Transicold. I'm Associate Director with Carrier Transicold, and I'm located in Syracuse, New York. I've been with Carrier since 1993. Let's go to the slide. Today in the agenda, we're going to talk a little bit about the background and context for Carrier Transicold's use of CO2 as a refrigerant in our reefer containers. And also we'll talk about a current interesting use case of natural line that highlights its main benefits, energy performance, challenges, and solutions in the industry. The container refrigerant transition history. The refrigerant transitioned initially from CFCs to HFCs. CFCs are chlorofluorocarbons. Those were the main refrigerants like R22. Most of you would have been familiar. Those about 30 years ago, it was switched to HFC, hydrofluorocarbons. Basically, they removed the chlorine because of the ozone depletion potential associated with it. And that drive happened in the 90s. And pretty much most of the units that you see in the field now are 134A. About 1.4 million units are operating reefer units in the field, of which 92% are using R134A, which is a HFC. And also there is one manufacturer that uses 404A, which is a blend. Blend refrigerants uses a uppercase letter at the end. And that is also HFC, but it's a blend of 3 refrigerants. So you can see that pretty much every unit in the field, except for very few old units, they all have transitioned to HFCs now. The main drivers that drives this transition is factors such as the safety, performance of the unit, the refrigerant, and important one, GWP, global warming potential of the refrigerant, and also easy availability of the refrigerant around the world, and the cost of the refrigerant. Some of the regulations talk about in the next few slides. The EU, European Union, has the F-gas regulation, and this applies since January 2015, and it replaces the F-gas regulation that was in place earlier, which is in 2006. And this has GWP limits for the refrigerant that you use for different applications, like a domestic refrigerator, room AC, stationary refrigerant, things like that. And they put in different limits for the different applications. Obviously, for some of the really difficult old support equipments, they let the GWP remain a little bit higher, but they were going to drop them as well. But you can see stationary refrigeration and equipment servicing bans were the one that they allowed a little bit higher GWP, but the other ones, they were aggressive to drop down to 150. And the timing, you can see most of them are 2020 and some 2022, and they're slowly trying to enforce those. The other global regulation industry is the US EPA, Environmental Protection Agency's SNAP proposal regulation, which also imposed the limits on certain refrigerants, specifically tied to certain applications. And they were like a motor vehicle AC, aerosol propellants, and things like that, retail refrigeration. Most of them kind of impacted the foam. The refrigerants are used in foaming and as a propellant. So those kind of took the initial hit. And most of those are in place since 2016 now. This slide we see on the US EPA SNAP proposal. They requested additional comments on possible delisting of a couple of high GWP refrigerants, which are 404A and 507A. Their GWPs are in the 3900. And as a reference, the 134A that is currently used in majority of the reefer units, they are 1300 compared to the 3900 of these two, which are like 3 times higher. So those refrigerants were listed there for possible delisting. There's discussion based on inputs, feedback from the industry. And those were applicable to cold storage warehouses, ice machines, and things such as those. These refrigerants are used for high capacity and low temperatures refrigeration applications. So those were also considered. The next one is the Japan proposed regulations. They also imposed regulations on different refrigerants based on the GWP limits, and anywhere between 100, 150 to 750, 1500, depending on the application category of the product category. And they had different years spanning anywhere from 2018 to 2020 to 2025. And overall, the summary is, if you ask what does this imply to the refrigeration units or reefer units, there is no direct regulation that implies to the container equipment, because container equipment is a global product, and the use of refrigerant by the reefer containers are small. So these industries did not want to tax, and they go from anywhere from developed countries to third world countries. So they did not want to affect the global trade. So they did not include the container equipment in these regulations. So at the moment, there is no direct regulation that drives the refrigerant for the container industry. But the actual impact comes from the refrigeration pricing. If and when the 134A becomes more and more scarce, maybe some of the third world countries it'll be available, but eventually it'll move away from them as well. So then those refrigerants will be very difficult to get, and their price will be high. So indirectly, these regulations drive the refrigerant that will be used in the container product. So the alternate refrigerants that are being looked at are the HFO, hydrofluorooxygenated refrigerants, and the chemical blends of that, and the natural refrigerant like the CO2 we talk about in a little bit. This shows a little bit about the regulation. The ASHRAE, American Society for Heating and Refrigeration and Air Conditioning Engineer, classifies refrigerants into both flammability and toxicity category. There are two groups. On the bottom x-axis, you see low and high toxicity. The left column is the low, and the right column is high toxicity. And they use alphabet A for low toxicity and B for high toxicity. And on the horizontal lines, the top one is the high flammable refrigerant. Based on the temperature at which the flammability occurs, they group them into high, low, and no flame propagation from the refrigerant. So the top one is a category 3, the middle one is a category 2, and the no flame propagation is a category 1. So most of the refrigerant that is shown here in the green box is A1, and that's the refrigerant that is predominantly used in the container application. They're low toxic and no flame propagation, very low flame propagation, basically. So the 134A is in that group, and the 404A we talked about, and the previous refrigerants that were used 30 years ago or 22, they're all falling into the A1 category. And the one that's most talked about, the HFO refrigerant 1234YF, which is used in the automotive industry is adopting. That technically did not fall into A2. It fell into A2, but it had a lower flammability. So the industry fought for setting up a new category called A2L, L for low flammable. So that's where the 1234YF falls under. Still a low flammable refrigerant, but it is on the lower level of the middle category. So it's A2L. So it is still flammable. So that is why there are some regulations that forces them to be to limit in certain applications. And if used in certain applications, like in a closed space or in a refrigeration container products, you need to have additional sensors, which are visual and audio signal sensing. So those are mandated if you are using A2L or A2 or A3 refrigerant. A3 is the propane. Propane is A3 that some of you must have heard about in our products. Like one of the manufacturers was promoting that, and eventually they realized it takes a lot of effort to apply A3 refrigerant like propane into a container application due to safety concerns. There are refrigerators, small refrigerators, because if they leak into the room, they still do not exceed into the flammable range, even though the refrigerant is still flammable, because when it mixes with the air in that room, large room, it is basically small amount of refrigerant is used in the refrigerator. So even if the full refrigerant leaks, it still doesn't come into the flammable zone or combustible concentration. So that's how it's used in some small refrigerators at home. So when we look at all this, the important one is natural refrigerants such as CO2, which has a very low GWP, such as 1, has a high adoption rate or acceptance by the industry because of its being safe and low GWP. We'll talk a little bit about the flammable refrigerants if used in the transport. What is the regulation that governs, and how does that safety risk is realized? ISO 5149, it is a standard, international standard that covers the refrigerants that are used in products. And all refrigerants have a low flammability limit and high flammability limit. This is the concentration of the refrigerant to the air. So only if that ratio of the refrigerant to air is in between the low and the high range, it will combust. If it is below the low range, if there's very little refrigerant in the air, it would not burn, however you ignite it. And if it is above the high concentration limit, also there is not enough oxygen for it to burn, so it would not combust or explode. So a case of a 40-foot container with 80% loaded cargo is considered. So you'll have an empty space in that, which will be a 20% volume of the 40-foot container. If you look at that, and if you assume that the refrigerant leaks into the empty space, if all the refrigerant, if you had a rupture or a leak in the evaporator coil or low side of the coil, and it leaks into the system, you can calculate what the refrigerant amount would be when you compare it to the refrigerant concentration limit for flammability. What we'd end up with the propane is, in a container application, the propane amount required for the same refrigeration unit is less because of the way the system is designed, the refrigeration system. Propane has different capacity. So you would use about half of the refrigerant, 2 kgs. But if all of them leaked into that empty space of 80% loaded container, you'd get 8.5 times the refrigerant concentration limit. So that is quite a bit into the risk region. And the standard ISO 5149 has a 4 times safety factor. So 4 times 8.5, 34 times it's above the allowed limit by the ISO standard. The ISO standard uses an additional safety factor of 4 is because when refrigerant leaks, there is nothing that ensures that it is going to be uniformly mixed. So you can have certain concentrations, higher concentrations in a stagnant area, because the refrigerant, most refrigerants are heavier than air. So they would end up in a lower space. And if there is not enough mixture, you can have a higher concentration from the leak in certain regions. That's why they use a 4 times the margin. So bottom line, with the propane, you have, when your refrigerant leaks out from the reefer container with the 2 kg, it would put you into about 34 times the allowable limit by the standard, basically violating the safety risk, which mandates a lot of sensors and a lot of protections to be put in place. Otherwise, you can have a flame and an explosion, in fact. Same if you use a 1234 YF, that refrigerant, when you design it for a reefer unit, it takes about similar charge based on its properties. So current units are around 4.5 pounds, 4.5 kgs. So the 4 kg charge, if it leaks into the system, you would have a little over 2 times the refrigeration concentration limit for flammability on the low flammable limit. That equates, when you multiply by 4, according to the standard, it's about 8.5 times more than what's allowed by the standard as a safe limit. So the 1234 YF also poses a high risk and will require a lot of sensors and other mitigations in order to contain this risk. So these refrigerants, anything that is not an A1 refrigerant, poses a risk. Moving to our CO2 refrigeration unit, it's called Natural Line. It is first natural refrigeration container unit, and it is built upon a very similar platform in terms of like fans and controller and the basic stuff. It uses very similar components as our standard unit. It's 134A unit, HFC unit, but it has certain special components or unique components because of the higher pressure that the refrigerant CO2 refrigerant need to operate at. The pressures at which this unit need to operate is higher because of the refrigeration properties. The 134A unit is design pressures are 500 psi, and these are design pressures are 2000, little over 2000 psi. So it's a little higher pressure, about 4 times. But we operate a lot of equipments, high pressure hydraulic, and all those equipments operate in high pressure. But the components need to be designed to handle those pressures. So in this case, the unique components in the unit are, it's a special purpose designed multi-stage 2-stage compressor, reciprocating compressor. And we also use 0 GWP insulation foam, which is now our standard even on our 134A unit. And it uses a gas cooler heat exchanger. It's called gas cooler instead of condenser because the refrigerant state doesn't change in a normal unit because of the properties. On the high side, the refrigerant coming from the compressor condenses and becomes a liquid. That's why we call it as a condenser, that heat exchanger on the high side. But here the heat exchanger on the high side is called gas cooler because the refrigerant enters in a gas phase coming out of compressor into the heat exchanger and leaves also in a gas phase, not liquid. And we also have a flash tank there. It's a vessel like a receiver that's on the high side. This is on the mid-stage pressure, and it is like an economizer or a heat exchanger where it holds liquid as well as vapor. We pull the vapor from the top and the liquid in the bottom. As you pull the vapor, it gets cooled, subcooled. So it's basically kind of like a heat exchanger. So that flash tank is there. You can see it is on the left bottom corner. And it's again on the mid-stage pressure. There are 3 pressures in it: high side, mid-stage, and low side suction. And then we also have a variable speed drive. Some of our competitors units have variable speed drive. The same kind of a variable speed drive is used to drive the compressor, and it has advanced software and controls on the same controller that is used in our current unit. So these components are unique, but overall operation of the unit and servicing is not much different. Moving to the next slide, talk a little bit about the efficiencies of the natural line unit. Here we show 3 operating points of set points The cargo set points are 14C, like bananas, a lot of tropical fruits, and 0C, which is another common set point, a lot of leafy vegetable, grapes, several fruits are in the 0 to 3C. And then another common commodity that a lot of the frozen cargoes are carried is -18C. So looking at these three, we are looking at 25C, because majority of the time the reefer containers are exposed to ambience 25C or less. There's been a UNEP report where you can see that statistic data. So looking at the operating point at a 25C ambient, you can see that the green bars are the power consumption of a natural line unit, and blue is a reference of our industry leading prime line. So when you compare that, you can see at the part load of 14 and 0C, the natural line consumes a lot less power. And on the frozen, it is a tab higher than the standard 134A unit. But overall, as you can see in the perishable cargo points, it operates a lot more efficient. And overall, the power consumption of natural line unit is very comparable to the 134A unit. Moving to the next slide, it's on the service training. CO2 training has been a part of our standard offering. We've been training our depots and service technicians for the past few years, and we have training modules. People can sign up and take the training. We have 400 plus authorized support and service repair centers with the parts available. There's natural line parts available readily. And we give fundamental refrigeration training, comparing the 134A current product and with respect to the CO2 unit, it's called R744, according to ASHRAE classification, and how you work with the refrigerants and how you service the tubings. The tubes are a little bit thicker, but it's very similar in the brazing, and how you operate the refrigeration unit, the natural line unit, and how you troubleshoot and how you service the unit, evacuate, charge. All those are covered in that. And the next slide, I would like to just mention about one of a unique application where natural line is used by one of our customers. It is in a stationary storage use case where they're using it for a grocery as a grocery vending machine. So you can see in this picture, our refrigeration unit natural line is mounted in the back side, and it's not accessible for the normal consumers. And on the front side, they have a console, a nice console where you can come and scan your order, and you can place the order through internet or through the phone, and it'll tell you when the commodity is ready, the items you ordered. And they have two compartments in this. On the back side where the reefer unit is, they have the freezer section. Then they have a internal compartment which controls the second chamber at a perishable temperature. And they have both perishable cargoes like milk and other products. And then on the frozen side, they have meat and other frozen peas, frozen vegetables, all those. So when you place the order, their staff gets the items loaded in a bin with the tags on it, with your order number in it, and inside they have a system that scans it, and he loads it on the two sides. In the front, they have two doors through which he comes periodically, and then he loads the goods, and then those goods goes through a conveyor and then get stored. So when you scan it, if it is a frozen, it brings the frozen part of the box, as well as if it is perishable, it brings the perishable, and you pick up all your goods, whatever you ordered, it comes. And then once you take them out from the doors, then it closes. So this has been successful, and they're slowly deploying in some of the European and Australian and other New Zealand market, and now they're introducing in the US as well. Walmart and some of the few big companies are looking at it. This has a very good application where in like big cities, people can just place the order, and then the evening as they come by, they can just pick up and go home. So this has been a very interesting application where we see that the consumers are interested in. And there are a few other applications where natural lines are used in a stationary application, but this is one we would like to highlight. And I think in the days to come, you would see more of the natural line being used for various applications and reefer cargo transport. With that, I'd like to say thank you for your time and have a good day. Bye.
So we have just heard the video from Mr. Suresh representing Carrier Transicold, discussing, introducing the natural line. So the natural line, we don't all see it as an application for the marine transport of the food, but as was also mentioned, the application can be static. And as you all know, Philippines consists of thousands of islands, and there is a need for refrigerated space located in off-grid locations at the islands, close to the harvest locations as well. So post-harvest facilities could benefit, and we have received a number of inquiries about possible solutions. So we look forward to having this technology exhibited and run at the Coach Innovation Hub, and we are excited to also help organize the training and introduction of these technologies to the industry. So very excited about this contribution, and we thank you again to Carrier Transicold. As mentioned before, Mr. Suresh could not join us live today, so we have had this pre-recorded video, and we have received a number of questions. We'll make sure that we will pass on the questions to Carrier Transicold so that the answers can be provided over email later on. So thank you very much again. I would like to welcome our next speaker, Wynand from Future Green Now, who is no stranger to the Coach Innovation Hub activities. And Wynand is going to be talking about their contribution and their expertise when it comes to design, consultation, training on natural refrigerants, especially CO2. Welcome again to the virtual floor of the Coach Innovation Hub event. Good to see you again, Wynand.
Hi, Jan. Thanks for having me. Happy to be here.
All right, so sharing, and you can go ahead and share with us your slides, and we all look forward to your talk.
Great. Yeah, thanks for having me, and we're very excited to be a part of this initiative and looking forward to contributing as much as possible.
Thank you.
Just see if I can. There we go. That should be sharing my screen now fully. So yeah, today just wanted to give a little bit of background, as Jan said, on basically firstly who we are as a company, what we do, and then secondly what we plan or feel we can contribute towards the Cold Chain Innovation Hub within the Philippines. So firstly, we basically are an independent consulting company specializing in CO2 as a refrigerant. So our work includes concept design, product design, and supporting either OEMs, contractors, or end user towards their journey towards using CO2 as a refrigerant. Our experience or our background is about 15 years of working with CO2, specifically in and around Africa. So giving us a lot of high ambient experience, I guess, in designing systems for these higher temperature areas. Our experience also includes the physical design as mentioned, but also manufacturing, installation, and servicing of R74 related products or projects. So around that experience, we'll see and we will try and contribute as much as possible towards, I guess, the understanding of CO2 and the uptake of CO2. Just a quick bit of a background of currently projects that we are busy with. So although we are based in South Africa, we do operate internationally. We have a few client bases spread out around the US, obviously Africa, and then Australia as well. And everything, like I said, it's either from supporting CO2 product development for certain clients, full industrial turnkey solutions, design, build, supply. We also like to take an holistic approach, and I'll touch on that later within the presentation, on incorporating a lot of all the heating and cooling requirements within a facility to ensure a fully sustainable facility. So that's basically just where we are currently operating. Then, as I said, what we can contribute, firstly, number one is training. So we can contribute in terms of theoretical training, which will go into the in-depth understanding of how CO2 operate as a refrigerant. Certain characteristics that needs to be implemented within the product or when utilizing a product to be understood. For argument's sake, one of the major differences between a CO2 refrigeration system compared to an HFC-based refrigeration system is the transcritical point and the transcritical operation of CO2, where you have your additional, in most cases, you have your high pressure valve and flash gas valve to control certain pressures around it. So obviously we can give some insights around transcritical operation, how to utilize that in the design of your systems or installation of your systems, servicing of your systems, and then as well certain venting, charging, and safety training aspects that we can touch on. From a technical aspect, what we can bring as well is we can help contractors and users of products to implement and take these products to market, which would be around the installation design of these units. So either pipe sizing, electrical requirements, electrical design, then also component selection like electronic expansion devices, which valves to be used, pressure rating, how to size your system according to your pressure ratings from a safety point of view, and then also a very practical point of view. And then also we can give some inputs and help around application designs, which is incorporating heat reclaim or air conditioning, chilled water, or various other temperature requirements that can be within a facility or requirement of a facility. So we can also looking to contribute towards looking at these various ways of utilizing CO2 as a refrigerant. Knowledge as well. As I mentioned, we've got about 15 years experience with working CO2 from retail to industrial, heat pumps, chillers. So we can look at sharing our experience, what we have shared, what we have experienced in the past, what is important from a technical point of view. For instance, if you are a service provider, what is important for you as a service provider, and what is required to maybe train your technicians up, or what type of system to look at to ensure that you have a simplistic system that can be utilized and serviced by technical capabilities that's available. And then also best practice sharing. So we have learned from the past what is required, what's not required, what can simplify systems, how can you offset standstill pressure, how can you design for higher pressure ratings, and so forth. Also introducing case studies. A lot of what we do is case studies for end users and clients and contractors to showcase what technology might be used under certain circumstances. A lot of questions come through where it's like looking at CO2 from a high ambient condition is when do we use certain technologies as parallel compression, ejectors, boosters, adiabatic, and a lot of these are incorporated sometimes unnecessarily. So we can also help with case studies to say, like, if you have a certain ambient condition and availability or certain geographical location, what might be the best solution for you to put onto your system to firstly drive energy efficiency and also whilst maintaining simplicity and cost reduction. For instance, a lot of these technologies do work against each other. Adiabatic is for adiabatic gas coolers, for argument's sake, is the utilizing of water to get you down to operate your system under wet pulp conditions. So basically what that does is it reduces the discharge pressure of your overall system and make you run at a lower, either from transcritical, take you back into subcritical mode. So what needs to be understood is, for argument's sake, parallel compressors or ejectors work and contribute to energy efficiency when it's running at high discharge pressures. So it's finding a balance between these technologies to get the best out of them and not to have them fight each other as well. There are various other energy improving methodologies that we can showcase and introduce. Some are just literally design based, which can really increase the overall energy efficiency of a system. A simple example of that, for argument's sake, is if you just look at the suction temperature of a refrigeration system. For every 1 degree Celsius that you can increase your suction pressure, you basically save about 3% on your overall energy efficiency. So small little energy efficiency improving methodologies can be showcased and studied and shared with everybody that might be interested. And then also, like I said, how to take an holistic approach. What is in which ways and what's the various ways that air conditioning can be introduced onto a refrigeration system. If you're looking at a cold chain system, how can you utilize condensate water back to improve the efficiency of your system? What part does good cold chain play in your role? Have a good receiving area, have good isolation of temperature to ensure there's no leakage of temperature. So a holistic approach and steps towards that. This is kind of just facing or showcasing back on what we mean and what we can showcase and share in terms of, like, as I mentioned, case study point of view. So what we do is we do utilize software where we can write up software system that can simulate a refrigeration system. We can then utilize that refrigeration system to showcase various operating conditions and showcase different technologies against each other. And then we can go and state that, for argument's sake, Manila, Philippines, take the annual ambient conditions, showcase, work that into the software, where the output can then be to showcase an annual energy saving percentage or comparison between different technologies, to help drive decision making in what is the best technologies and what might be the best solutions to utilize when working on a CO2 refrigeration system. CO2, why do we like CO2? Firstly, I think it's been touched in the previous one as well. It is a low toxic, low GWP, very safe refrigerant to use. It's capable of catering for a large variety of applications, and it's definitely taking off worldwide. Technology is really driving the uptake of CO2 as a refrigerant. So it's environmentally benign. It's been showcased to have energy efficiency contributions towards refrigeration systems, so definitely has been proven to be an energy efficient solution, and also can be helped to take into further reducing off-grid solutions and complete cold chain solutions. CO2, like I said, does have a certain properties and does have certain capabilities to allow you to introduce additional requirements. Heat reclaim, for argument's sake, for CO2 is a really big benefit that can be received out of these systems. You can manipulate the discharge pressure, for argument's sake, to make sure that if you have a requirement for high water temperatures, even if the ambient conditions might be lower, you still can utilize your system to give you the water requirements that you need. And that kind of that reduces the requirement for additional heating solutions, which might be boilers or heat pumps or anything else within a facility, as well as incorporated chilled water that can be utilized for either air conditioning systems, as well as, how can I say it, food processing facilities where washing might be required, or a process might require chilled water within itself. Then the overall impact to utilizing CO2 has a massive impact already on your global warming potential, or your greenhouse gas emissions of a cold chain or refrigeration project. Firstly, being that if you're looking at a total equivalent warming impact, your first contribution to your TUI is basically direct emissions, which is due to refrigerant leakages. Utilizing CO2 as a refrigerant basically already takes that out of you, takes away that contribution to global warming or greenhouse gas emission already out, and then also indirect emissions, which is due to the power that you use. So depending on the type of power that you use, but as well driving a lower power consumption leads to a lower greenhouse gas emission. So basically taking everything that we've done here, just one or two pictures, or just maybe through one project that we did do in South Africa, where we tried to, or where we kind of incorporate all this holistic approaches. It was a fairly large facility, up to about 5 megawatts of overall installed cooling capacity, various temperature requirements from freezing to medium temperature, also the capability of switching the loads. So for argument's sake, we had 4 main rooms, which in fruit season is utilized to sterilize fruit. So we were running that as cold rooms and sterilization rooms for exporting fruits. In the off-peak season, we have the capability of switching 1 to 4 in any way that we want over to freezer rooms to cater for freezing products in the off-peak season. Within this facility, we did air conditioning off of the refrigeration system for the office space, hot water for the underfloor heating, as well as domestic requirements. Condensate return back to be utilized for the adiabatic condensers. And then this facility's heating requirement, for argument's sake, was not as big for all the free heat that is available within this facility. But one of the nice things of this facility, and which was quite nice to do, and that we are currently still looking at and incorporating, is right next door to this facility, for argument's sake, is a textile facility. And this textile facility utilizes lots of water, hot water on a daily basis to produce clothing and material. So basically, we are going to capture and utilize the heat from this facility, move it next door to offset the use of coal.
Okay, we have lost connection with Wynan, but hopefully he will be back with us soon. Let us wait a couple minutes. It's great to see these pictures. We're very happy that Wynan could add them. It's a massive facility, but what we love about it, it's just stunningly beautiful. It's very clear. It's a brand new facility, so this is what we find as beauty after 10 years in the industry. So let us see if we can reconnect again with Wynan. We have lost him for time being. This was also his last slide, if I'm correct.
Yeah.
So we may proceed with our next speaker, and then we can have.
I want to quickly show some of the.
Yes, please go ahead, Devin. So my colleague Devin will share a screen with you, and this is our YouTube channel. And on the YouTube channel, you can actually find a number of technical trainings and contributions from Wynan that he has already contributed to the project since last year. So you can find more details about their work and the CO2 expertise that he's sharing with us. So please also refer to the YouTube channel if you are looking for more detailed information about CO2 and the expertise that Wynan and Future Green is going to share with the Hub. So unfortunately, it seems we have lost the connection. So we will then proceed with the duo of our speakers from Panasonic and Hussmann. So I'm very happy to see Greg already joining us. Please, Greg, join us on this screen. Good to see you again. How is everything in Australia?
Things are great. We've finally come out of 262 days of lockdown. Not that we were counting, but yeah, we're very, very happy. And further restrictions get relieved this Friday. So sort of food retail's always been open with the exception of cafes and restaurants, but restaurants are back, and you know, general retail is also back. So it'd be great to go to the shops and buy some clothes, yeah, rather than online.
That's very good to hear. Please all stay safe, and then hopefully this will all be behind us, and then next year we'll be, we'll be able to meet each other again, and we'll be able to, work with our customers on the ground and then see some of these technologies that you are installing in the market. So we have just heard from Wynan from Future Green Cool, and all about their expertise with CO2. I'm very happy to have you and Mr. Shimada to speak about your solutions, your CO2 showcases, and also the condensing unit. And this particle installation that you will be introducing, this concept, it will be the first CO2 transcritical retail application in Philippines. So it's a huge milestone. We are very happy to work with you. and have this installation as a part of the Culture Innovation Hub to be used for training, awareness raising, really setting that, reaching that important milestone for the industry and the CO2 transcritical technologies. So thank you again for being part of the project, and we all look forward to your presentation. That is also joint presenter will be Gaku Shimada after your slides, I believe, to introduce also the condensing units.
Yeah, and we'll be just following through on the same set of slides. So I'll just continue sharing my screen as we hand over to Gaku Shimada. But it is with pleasure to represent Panasonic and Hussmann today, with all like-minded organisations that have a common goal of making contributions to preserving the environment and enabling cold chain solutions, not only for the Philippines, but the broader regions throughout the Southeast Asia and Oceania, where Hussmann is particularly focused. At Hussmann and Panasonic, we are really focused on creating true contributions to society, enabling a better life, a better world for all. Personally, this is one of my favourite slides, and used across a wide range of presentations, but I particularly love this statement from the founder of Panasonic, Konosuke Matsushita, and it's as relevant today as when the statement was first made. And hopefully during today's presentation, you will feel that these philosophies run deep within the Panasonic and Hussmann corporations. And I'll just make note of that our human society is progressing day by day, and products should as well. And there's no more relevant time to meet these challenges. This Hussmann is a 116-year-old company, first founded by Harry Hussmann in 1906. And innovation has always been at the forefront of the business, and those same traditions continue today. And we're constantly evolving, finding new and better ways to meet the needs of retailers, so you can give your customers the best possible food quality and shopping experience. So just as innovation is at the forefront of our business philosophy, the Hussmann promise is a significant part of our culture and the key reminder of how we have chosen to compete in the marketplace and the future value we aspire to deliver. The new era with Panasonic is also enabling the Hussmann promise: better business, better partners, better world. And by enabling new technology-driven solutions like transcritical condensing units partnered up with Hussmann showcases, shelf-edge technologies, and new products and services in meeting the digital era to drive new consumer experiences, but also enable sustainability initiatives like shelf labels, refrigerated lockers, and ability to capture data like never before. This slide attempts to provide a bit of a graphical overview of our Hussmann manufacturing footprint, but also it includes the Panasonic manufacturing footprint across the region as well. And we're also supported in the Oceania and Southeast Asia region by our Hussmann Suzhou facility, and that is our key core facility of where we provide product for China, for Southeast Asia, and Australia, New Zealand, and across the Pacific Islands. Australia is also our region's Research and Development Innovation Centre for Excellence, with supporting laboratories in Suzhou, China, and New Zealand. On this slide, as we mentioned in our opening slide, that we at Hussmann and Panasonic are focused on creating two contributions to society and enabling a better life, a better world for all. So I won't run through our sustainability journey, which is pinpointed there at 2016, and we can take it right back to into the 2000s. But more importantly, what I'd like to do is run through some of our sustainability journey over the next period of 2022 to 2025. As part of this journey, we have a number of several planned actions. Launching in 2022, Hussmann's most energy efficient multi-deck case, with a big focus on operating life cycle carbon emissions, but also a critical focus on case materials and recyclability of the case at end of its life. In 2022, we will also be launching our brand new innovation centre in our Australia Sydney Glendenning facility. It's a brand new build, replacing our old facilities, and the test lab facilities are also being brought right up to the very front of our operation here into Australia. So it is a more innovation hub, not only internally, but externally for our key customers. Also, a number of technology solutions will be launched, including Hussmann to capture or to enable smart cases of the future and to be able to capture data like never before. We also have a sustainability target to reduce packaging by 45%. And that project is kicking off so we can establish our benchmarks across a baseline of 10 stores here in Australia. 2022 will also be exciting as we look to launch our 25 by 25 sustainability initiatives, with a key focus on creating safer environments by inhibiting viruses, bacteria, and allergens to increase hygiene, food security, and increasing product freshness and reducing waste through our NanoX product, which is a proprietary Panasonic product to be integrated into our products, and focusing our new product development programs specifically on net positive carbon emissions. This slide gives you a snapshot of some of the new products that we will be focusing on for 2022, but also the technology solutions that we will be looking to incorporate into these particular products. So you can see in the lower right there some of the self-contained merchandising solutions, as well as some of our larger format merchandising solutions, and the refrigerant solutions across our new product line, specifically targeted for CO2 and R290. We'll also be focusing on shelf edge technology products to reduce energy consumption for new display cases, but also as part of existing assets for retailers to improve not only energy consumption, but temperature compliance for those existing assets. I mentioned before NanoX. So NanoX will be a big part of our product launches in 2022 to increase hygiene levels, food security, increasing product freshness, and reducing food waste. Hussmann or Hussmart with data acquisition. So this will be with fully integrated sensors to capture new data that has never been able to be captured before in a refrigeration merchandiser to enable better asset management and customer engagement. And you can see there in the to the right-hand side, our refrigerated lockers from our Panasonic facility in China to continue to enable e-commerce solutions that will be fully integrated with natural refrigerant solutions and also NanoX technology. On this slide, this is really outlining our journey as a Hussmann Oceania team on their TCO2 experiences. So our journey for Hussmann Oceania started some 16 years ago in circa 2005, particularly focused on subcritical direct expansion CO2 for low temperature and pump liquid CO2 for medium temperature. And in the period of 2005 to 2009, we completed some circa 20 stores across Australia and New Zealand. At the same period, our journey was also evolving to a more simplistic hybrid system, so low temperature DX for low temperature and medium temperature DX R134 for medium temperature. And this was part of our product roadmap from 2005 to 2015 and is still part of the roadmap for, say, for some independent retail stores. But in the key period of 2005 to 2015, we completed about 50 stores across the Australia, New Zealand region. In 2013, it saw our first transcritical store opening with a number of validation and improvement stores in the subsequent years, mainly between 2013 right through to 2018. 2018 was a really significant milestone for the Hussmann Oceania team with our first transcritical 80-bar store right here in Melbourne, Australia, with Coles supermarkets. Today, we have over 150 stores operating across Australia and New Zealand on 60-bar and 80-bar systems. To the top right, you can see two images that's from, it was part of a social media campaign, I think around June, July of this year. And the campaign key objective was to really increase the awareness of CO2, but also to particularly target independent and smaller retailers within the Australian and New Zealand marketplace with a series of do you know or did you know campaigns. And you can see our journey from, this one is 2015, where essentially we might have been doing 1-2 stores per year. And then in 2018 to 2019, a progressive uplift of the number of stores that we completed. And then really in 2020 and 2021, with that volume being sustained right across the Australia supermarket retail landscape. The picture above shows that we've actually got about an even split of stores in Australia and New Zealand. It's about, call it 76-76, but also quite a mix of retail application. Majority of cases being applied to supermarkets, but as you can see there, 158 merchandisers dedicated to convenience or small format retail. This slide is just some images as part of the continuation of our supermarket or our CO2 social media campaign with a Did You Know theme. And you can see there with our social tags across LinkedIn, Facebook and Instagram. So please feel free to connect on our social programs. As part of this presentation, I think innovation has been a real key part of the Hussmann and Panasonic business philosophy. When it comes to energy efficiency, it's at the core of our DNA, and it's also at the core of our new product development journey, with that particular focus on not only energy reduction, but our carbon emission impacts. This slide gives you a bit of a graphical illustrative journey on the Hussmann energy impact from 2003 right through to our next set of product launches in 2022. So each one of these bars is representative of a particular merchandiser at that particular period of time. So you can see circa 2003 to 2010, between our multi-deck merchandisers, we had an energy saving of circa 25%. And when we break that down to an operating cost level, that's about $444 per 2.5 metre display case in a store per annum. But if we take the same journey between 2003 right through to our next generation multi-deck cases to be launched in 2023, you can see there that it's a 53% energy saving, or $931 per 2.5 metre display case when we benchmark right back to 2003, and then it's in the circa $500 saving from 2010 through to 2022. And you can also see there graphically that it's significantly reducing that energy impact between open refrigerated display cases, but also door showcases. And our innovative journey doesn't stop at open display cases. So you can see to the far right, in 2010, our introduction of door multi-deck cases, and then on the far right, the continuation of that energy journey to constantly reduce our energy consumption and our carbon emissions impact. On these next couple of slides, it's really just to give a bit of a illustrative snapshot of some of the refrigeration merchandisers supplied not only across the Australia, New Zealand region, but also within the Southeast Asia region. So here you can see our range of multi-deck cases. Primarily what we're illustrating here is full height multi-deck cases with smart look, all glass doors, and you can see they're being applied to dairy, but also meat case merchandisers. But also in the lower left, you can see the adoption of doors onto the lower height multi-deck cases with the overall height at 15 and 1600 millimeters. And then to the right, you can see a Hussmann multi-deck merchandiser in a store in Cebu from circa 2019. We also have a full range of low temperature merchandisers, all compliant on natural solutions with CO2 for both 60 bar and 80 bar application. But we also have a variety of door and lid solutions that can be applied to all of our families. So we have traditional door frames to the very visually appearing all glass door frames, which is the top right image, with a lot less visual impedance for the consumer. And then in the lower left, you can see lower height glass door freezers in both 1500 and 1600 application with the all glass door. We also sweep the lower height glass door merchandiser in with the medium temperature merchandiser as well, in both open and door format. To the lower right, you can see a photo of a coffin case or a White Island freezer case with the push-pull lid solutions, but also the 1 and 2 tier display system to enable companion merchandising for the product in the low temperature merchandisers. And this is a full complementary range of our deli case merchandisers, once again in CO2 for 60 and 80 bar application, and 3 of our different series. So the top left is our V series located in Brisbane. The bottom left is our D family located in Sydney, and to the right is our combination deli case series located in Melbourne. And finally, before I hand over to Gaku-san, we're committed to bringing sustainable, energy-efficient solutions to the market for the ASEAN and Oceania region. We want to create true contributions to society that improves the well-being and makes contributions by preserving the environment and supporting to resolve social problems globally. So on that note, I'll pass over to Gaku-san.
Thank you very much, Greg, and please stay with us, and we'll have some questions after Gaku's presentation as well.
Okay. Thank you, Greg. My name is Gaku Shimada. I'm from Panasonic, Japan, based in Gunma Prefecture, which is a local place in Japan, about only 3 hours away from Tokyo. So it's my honor to speak about our CO2 product in this webinar as one of the technology leader companies. Thank you. So today I will talk about Panasonic transcritical CO2 compressor and also transcritical CO2 condensing unit. This slide is explaining our history of compressor. We started the development of CO2 hermetic compressor in year 1997 or 8, and we started production in year 2001 with small compressors. Our main application was heat pump water heater, and also bottle coolers for the Coca-Cola machines. For these applications, we have sold almost 1 million of CO2 compressors. And with the same basic design, we developed the larger compressors, which we call 20 frame in 2004. And 2009, we developed 33 frame. Compressor output range is about 10 horsepower, this 33 frame. So as a total of our history, accumulated production of our CO2 rotary compressor is more than 1.2 million with 20 years of experience. Okay, next slide, please. So, in parallel to compressor itself, we also developed our application. One of the application is a condensing unit. We started production in 2010 in Japan. We got a lot of attention from the market, and thanks to government support, we have a lot of customers. Name of our key accounts are listed in left bottom. There are so many customers, and we already installed for more than 4,800 facilities. And total units we installed is more than 13,000. The number is increasing. And about 1,000 of these units are installed outside Japan. Our main market of outside Japan is Europe and Oceania. We collaborated a lot with Hussmann for Oceania market. And we also installed CO2 condensing units for Southeast Asia. We installed 24 units, CO2 units for Indonesia, 2 units for Malaysia, and 2 units for Taiwan, and some others. Yeah, but so far we have no installation for Philippines. Next slide, please. For last 2 to 3 years, we collaborated with Hussmann deeply. So as you already know, as Greg said, Hussmann has very nice display showcases which are applicable for CO2. Panasonic has a CO2 condensing unit. And we already got a lot of experience for Australia and New Zealand. And we share the knowledge with each other. So we are ready to deliver transcritical CO2 systems for Philippines as a Panasonic Hussmann team. Next slide, please. I think this is the last slide from my side. Greg, you can close. Thank you.
Thank you very much. Thank you both to you, Greg, and Gaku-san. Please stay with us. We will have a few questions. I would just first ask Greg a small clarification. In your presentation, you have mentioned 76 stores in Australia, but also in the same slide, there is a reference to 150 stores. Can you please help us understand this?
Yeah, it's across the, so the social media.
Sorry, the slide before, if you can display. Thank you.
Yeah, the social media campaign was primarily a Australia campaign, so it represented 76 stores, but in total across Australia and New Zealand, we have installed 150 stores, and that was a figure going back to June, so it would be more than that over the past few months.
Thank you. Very impressive numbers. And you have also helped. You have also shared with us a few pictures from Philippines, from Cebu. Just to understand, these would not be CO2 transcritical application, right? That's the conventional treatments at this stage.
Yeah, absolutely. It's just standard commercial refrigerants. But all of those showcases that we've installed within the Philippines environment, 100% of that range are fully available for transcritical application. So we look forward to the opportunity ahead.
Excellent. Can you please help our audience understand that you have a team on the ground that is then able to handle these new technologies as well?
Yeah, like I think the Philippines environment, this is about a training exercise right across all aspects of organizations to enable, the new technology. And within the Philippines cold chain environment, it's a skill set and a skill base that it will be expanding. But within the region, we are very well structured to support the cold chain, emergence to sustainable technologies.
Thank you very much. And I have a question for you, Gaku-san, if I may. You have mentioned, first of all, congratulations on the very impressive number of both the CO2 compressors installed in the market as well as the installations of the condensing units. You have mentioned your project in Southeast Asia, Indonesia and Malaysia in particular. Can you please share a little bit more detail about these particle installations? How long the CO2 transcritical have been running in these countries, and what is the feedback so far?
The oldest one has been running since year 2015 in Indonesia, 24 units, 2 units for 1 convenience store. So total 12 convenience stores. They are using 1 2 horsepower and 1 10 horsepower as a combination for 1 stores. And we are receiving a very good feedback from the customer. The unit never stops, and they do not check the energy consumption, but they are quite satisfied with performance. And some units in Taiwan, 2 units are running here since 2016, and 2 units in Malaysia since 2017. So they are running without no issues.
Thank you. I believe both the Indonesian project and the Malaysian installation have received some support from government as a subsidy. Do you believe it's the necessity still at this stage to support the first installation on the ground in Southeast Asia?
I don't know. It depends on customers, but if there is a support from the government, it will be definitely be supportive, helpful.
Right. Thank you. The Philippines, we understand that this experience can be very helpful for your experience with Southeast Asian installation of CO2 transcritical can be, of course, helpful for the project in Philippines. And the purpose of the Cold Chain Innovation Hub is to bring the stakeholders to the facility to make them more familiar with the installation, including the policymakers, and help create this increased awareness about the solution. So we are very happy to work with both Panasonic and Hussmann on this installation and to mark this the first CO2 transcritical on the ground in the Philippines. Is there any, in terms of first projects on the ground, what would you say is usually the hardest part? Is it the availability of the technology? Is it the training of the industry? Is it the maybe the convincing part, or there's a lot of hesitation usually, but are we now in the point that CO2 transcritical can be installed anywhere in the world and the efficiency, none of that is of an issue?
I'll hand to you, Gaku-san.
Okay. I think the energy consumption efficiency is not an issue because transcritical CO2 can survive, and efficiency is not bad, as it is sometimes said, even in high ambient temperatures. So the most difficulty is, I think, the training for commissionings, because CO2 is a high pressure. We need to do enough training to installers. Okay. And through our 2 to 3 years experience with Hussmann, Hussmann already know how to train customers. So I think the most important point is the training, and I think we are ready to do that.
Thank you. It's very reassuring to hear that. And again, we the Culture Innovation Hub, we aspire to help provide the training to the industry to really, leverage the experience and the expertise of the contributors such as Panasonic, Hussmann, and Future Green now and others. There's many institutions, including DTI, that we will hear from now. They are actually contributing with their CO2 training. So bringing that capacity to the Culture Innovation Hub for the industry to have an easy, free access to the CO2 training we agree completely with you that this is the crucial part to tackle. So thank you very much to both of you, Greg and Gaku-san. It was a pleasure to have you. And again, we look forward to working with you on this first installation, and also to help bring this technology to the market in the demonstration project next year. So thank you very much for your contributions.
Thank you.
Excellent. And I'm here also very pleased to welcome Christian from DTI. How are you doing today? It's good to see you again. It's been a while.
It's been a while, yes. Thank you. Thank you. Hello, everybody.
I have to just share a short story with the audience. Our CEO, Mark Chassero, he was actually speaking at the DTI event just, I would say, 2 weeks ago. And it was the first event that he attended in person, and he was saying how surreal experience it was, and how great it was to have your audience, and then some 300 people, sharing this common mission of bringing CO2 and other natural refrigerants to the table. So it was great to participate in your event, and DTI has been active on so many fronts when it comes to natural refrigerants. So I'm happy to first of all, receive your contribution from DTI in form of training and your expertise and knowledge as well, beyond CO2 transcritical, also the solar cooling aspect. But happy to have you here today, and again, looking forward to our cooperation and your presentation. So please go ahead with your presentation. Thank you.
Thank you. Thank you very much, and thank you for the opportunity. I'll try to share my screen. Please, do you see it now?
Yes, all good. Thank you.
Okay, thank you. I jumped right into it. I'm going to make a very short presentation of our CO2 training, but I will also mention that we also do training for ammonia systems and for solar photovoltaic installations. The special about our CO2 training is that we have 2 training rigs that we can ship around the world, and I'll come back to that. But first, just to show that the contents, this is the content of our the number of slides and the content of our training for our what you can say more or less standard 2-day training program. So we have around 200 slides and cover these subjects with very different system solutions, and with a lot of input from the activities from other partners over time. So we, just to run through very fast, we have the supermarket systems as a very important part, because that has been the dominating part of the CO2 market the last years, and also with the add-on of the high ambient designs, and most important in this in the practical training, but also the safety and the consideration of choice of materials with CO2 and the basics of the operation. I say that our training is very basic in the terms of we are not giving you or the trainees an introduction to the very large and complicated state-of-the-art supermarkets in terms of the controls and so on. But we give an introduction to all the basic designs, with also including ejectors and so on. But the control systems is better, the training for those are better placed at the actual manufacturers, I believe. We would be able to do a more comprehensive training in the control systems, but that will require a separate training course. Then we have an introduction of the pressure directive and the sizing of vessels and piping. I don't know what if we are going to train at some point in the future for the Philippines. I don't know what kind of standards and codes they use, but we are based in Europe, so far our materials based on the European procedures and regulation. And then we have the presentation of the different components and how they perform. We also have sections on CO2 in industrial systems. And the last part, the selection and size of main components, are explained later. That is something which could be tailored to the needs of the trainees or the actual setup. I'll try to change the slide, which seems a little bit slow here. The backbone of our CO2 training is based on our activities in CO2 for more than 20 years. And what you see on the large picture here is our CO2 ammonia cascade, which is still in operation and is operating many of our tests. We do lab tests for customers, valves and evaporators and so on. So we make performance tests and so on. And a lot of that knowledge is also what you can benefit from in our training course. But our actual test or training setup is not based on this unit. It's based on smaller units that I will explain later. But they were made initially as to promote CO2 training in Denmark and in Europe as general. And we also been involved in testing materials with CO2 with high pressure testing and so on an early stage. Of course, we introduce CO2 and compare with the properties with other refrigerants or the theoretical basis of CO2. And we have the introduction of the CO2 booster system, which has become more or less standard for the supermarket applications, but also include all the additional technologies now available, like ejectors and parallel compressions and so on. Our training rigs are special because they can be shipped on pallets. We have one cascade system, a very small and simple system, and a transcritical CO2 system, just a one-stage system. And then we have a set of vessels that we can do charging and discharging as a demonstration for how to make safe handling and also demonstrate what happens when you do not do it in the right way. These 3 rigs have been shipped around the world. We have been in UK, in Ireland, in Iceland, in Germany, and in Estonia. So it's possible to ship them around. It's always a bit complicated because we risk to have failures on the system when they arrive, but usually we are able to fix the problem so we can get on training on the actual site. So this is a possibility. Here's the subcritical rig with me in a younger version with more hair. We have 2 parts of the plant. It's a traditional, actually it's a 404A system, which is not so good for these times, but we never charged or recharged the unit for 10 years, so we assume it's not leaking. So the important part is the CO2 part up here, where we can do compressor stop starting, loading and unloading, and simulate various pressures and starting procedures. But even if it looks a bit complicated, it's made as simple as possible in order to get the basic understanding of the system. This is our transcritical rig, just a single compressor with an inverter based control, with a water-cooled gas cooler and a load by electric heater, so we can control the load in stages, and we can observe the system response on a live readout, a live pH diagram with the temperature and pressure readings, as well as, of course, the normal gauges. So we can experiment with different settings of the high pressure control, the different flow regimes, and so on, and see how the compressor work and how the absorbed power varies with the compressor operation. So again, it's not a supermarket system, it's just a basic tool to train and get the basic understanding of what CO2 do, and also to take some of the mysticism out of it, so we can people can get the what you say, the trust the system, even if this system works up to 100 bar. It's not dramatic, there's nothing mysterious about it, and that was one of the basic learnings that the feedback we get from people, that having a system with a hands-on experience is very beneficial for moving forward to the next step, actually building own operating systems. This is a rig we have with 2 vessels where we can charge CO2. We can see the very low temperatures we have achieved here with frosting on the vessel, and now one of the trainees here are thawing the vessel to build up pressure and see what happens. So this unit we can also ship. You see here a CO2 vessel here, CO2 bottle cylinder, and that has to be supplied locally as we cannot ship them with the equipment. The last, not the last slide, but the important part of the education and training with CO2 is the safety. So we have a run through of the safety, the design, and also the handling of leaks and how to avoid high concentrations in confined spaces and so on. So that's an integrated part of our training. I mentioned the standard and the legislation part, and we work from the CE directive, CE marking, the PD directive, and the associated directives, and make a very short introduction in terms of the pressure levels and so on associated with CO2. This part may have to be changed in order to the national legislation that is required to the site where the training is performed. And the last part here is actually something that we could design to the need for the trainees, where we go through different manufacturer software and introduces the compressor selection, the science issues, depending on the ambient, the summer conditions, the temperatures, the selection of the main components, such as the gas cooler, or maybe also evaporator and so on, and the considerations of the piping, so that we can make an actual basis in a system that is relevant for the trainees. We can handle all the questions that arise in that scenario. Our standard training is 2 days, but we also have had training with duration of 4 days with visit to different sites with installations. But of course, this very much depends on the location where we perform the training. So we can make a more or less standard training, or we can also make some more tailored versions of this training course. That was all from my side, and please, if you have any questions, you're most welcome.
Thank you very much. Thank you very much, Christian. This was very interesting. I have a few questions for you in follow-up. You have, first of all, showed us number of the CO2 training racks. Can you please elaborate if, is there one size that fits all, or do you really have to come up with very tailor-made solutions covering different functions of the system, etc.? In terms of, you know, the hardware that is necessary. That's one question. And the second question is, given what is happening, you know, with the pandemic and lockdowns and, you know, lack of travel, to what extent organizations such as yours can offer such training virtually online, you know, without access to these training rigs for the audience?
Yeah, we do online training as well. But it's of course a quite a different experience. But all the main topics we can of course handle in online training, no problem. So we have no, what to say, limits or restrictions on this. So we can also make a tailor-made online training, or we can make shorter versions of a CO2 training. We have had shorter introductory CO2 training also already online. But as our CO2 training always has been based on the rigs, has been our main focus. But there's no issue at all in doing the training online. Something like half or a little more than half of the training course is already the presentation of the slides. So and if you do a tailored training, you could select which part of the training should be more focused. It could be safety, it could be, you know, component selection, or it could be general theoretical approach. So yeah, anything is possible, but we can base our training in our standard training course like this one.
Thank you. Allow me to just, in addition, to ask, you mentioned while showing one of the training rigs that you mentioned that you are able to ship them. Is it common that you would ship these rigs to the location when the training takes place?
Yeah, it's something that we have done during the more than 10 years. Of course, during the COVID closed down, we haven't done it. But the year in 2019, we had a training in Estonia, so we shipped them. We haven't been outside Europe, you can say, with the training, but it should be possible to ship the units around the world. Of course, there will be some considerations about the cost and so on, but it's in principle possible. They have been shipped around already a lot of times.
And my final question is: do you see, you know, when we talk about tens of thousands of CO2 installations around the world in mostly retail refrigeration, can the conventional systems be also used for training of the industry, or do you believe in? Of course, I mean the highly specially developed training rigs that they offer much more functionality, but can you work with conventional system that is simply identical with installation in supermarket or convenience store? Yeah, that's no problem. The only thing is, for a training perspective, when you are introduced to a supermarket system, which many more components and the more advanced controls and so on, you have to work through the system in a systematic way. But basically, any system can be used for training if you have the owner of the system have no objections. The thing is that you cannot usually on a live system do so much changing of set points and so on, because then you will penalize the operation of the system. But on the other hand, you can show many things on a live system, and also
we did that for ammonia training, where we did not have the possibility to ship any rigs. So we went to a local site and run through all the equipment, and they had the actual installer tell also about the system. So we can base the training also on what equipment is available, and that is also, of course, the case for the photovoltaic and solar systems. So yes, that is also possible.
Thank you very much for this clarification. Again, we are excited to work with you and others, the experts of the CO2 transcritical refrigeration. So again, thank you for joining the growing number of contributors. Please stay with us a little bit longer. I will now hand over to Devin, and Devin will have a couple of questions for our panelists. We have now Wynand was able to join us again. So we can maybe start with a few questions for Wynand. Again, the training for CO2 transcritical really is coming back as one of the important topics. And this is where we see the hub to be playing a very important role in terms of helping to provide this CO2 training and other natural refrigerants training as well to the industry. So Devin, I hand it over to you, and let us start for about 15 minutes.
Sorry about that. Yeah, thank you again to Christian, Gaku, Greg, and Wynand for joining us today. I have some questions here, taking a look at some of the Q&A box, and see if we can hear from the audience as well. So if anybody in the audience has some questions, please go ahead and raise your hand. I'd be happy to bring you onto the microphone, see if you can address us directly. But I want to ask just one question just to get things kicked off here. This is for everybody, and actually maybe first I'll address Wynand. We have a lot of people joining us, not only from the technology suppliers, the end users, but also from the government and also from the general public and some of the academic institutions. I wanted to just ask each of you, and ask you, Wynand, what are some of the appealing aspects, or what are some of the rewarding aspects you've seen from your career of actually joining this industry, the sustainable cold chain industry, just in case we can have a chance to, bring more people in the Philippines to become more attracted to fill this training need to this industry, and even for people attending to sell it to some of the people that they know to spread the word. What would you say?
So I think the biggest thing for me that I really enjoyed of it is it's introducing something new. I think Freon systems has become very mundane, and it's like the same thing, and it's copy paste and put it in, and it stopped taking people away from thinking what they are doing and what they are putting into a system. The one thing that I've learned, even from technicians' point of view, it gets everybody excited again about refrigeration. It makes you think of what you put in, and once you start thinking about sustainability, once you start thinking about the global warming potential of a refrigerant, you start thinking about the energy efficiency of the system. Once you start thinking about the energy efficiency of the system, you start thinking, how can you save water? How can you put better lights? You start looking holistically at everything once you open your mind to why are you focusing on CO2. And then again, like I said, it always gets, what I feel is the biggest positive movement towards not just being sustainable, is that it really drives an increased level of interest in refrigeration, again, within technicians and end users.
Yeah, thanks, Wynand. Greg and Gaku, I know you guys have been out in the field with technicians, helping them commission and install these units all around the world. Gaku, you're active in Europe, and Greg, you're working a lot in Australia and New Zealand. What are some of the experiences that you've had with people you've trained who are newly introduced to these technologies? Some of the positive experiences that you've seen. Maybe you can, yeah, either of you could start.
Gaku, do you want to go first, and then I can go second? So
first we do about training using PowerPoint. It takes about 3 hours at maximum, and after that we do site support, on-site support. And if I witness one installations, they can do the second without me. So it's very easy.
Great. Yeah. So people are very, they take on to it very quickly. They learn very quickly is what you've seen.
Yeah,
yes, that's great.
Yeah, I would agree that I think if you look back over the journey, you know, there's been that sort of that fear of the unknown. But you know, we're lucky in this region now that we've got groundswell of technicians that are coming through that may actually not know anything other than natural refrigerant solutions for their new installations or major refurbishments. But even you know, for those that are servicing the smaller independent retail and the smaller retailers, so those smaller refrigeration companies, we've just installed 2 transcritical condensing units in Sydney. It's a refrigeration company, probably you know, only 10 technicians, and you know, that fear was almost you know, removed within the sort of the first day of it, having you know, our team on site working through the commissioning aspects, and you know, nothing but positive feedback. But certainly getting through that fear of the unknown is a big step.
Yeah, it'd be great to see once we get some of this equipment in the Philippines, and to have some of these technicians and people working on it and getting their hands on it for the first time. Christian, did you have anything to add? Maybe a positive experience you've had with introducing new people to these technologies?
I fully agree with both Gaku and Gregory. It's the first fright that you have to get over, and when people get the experience of how the system works, they adapt very fast. So of course there's a lot of learning when you're starting to look into larger systems and more complicated designs and so on. But the basic learning is that at first, when you first have established your own personal experience of the system, it's not that complicated, and people are generally very confident about the technology.
Great, thank you very much. We have some questions from the audience. Federico, Cesar, Adrian, and Mr. Kwong, I definitely want to get to your questions. So let's see here. I know we have Federico who's interested in answering a question, and we'd like to get you on microphone. Federico, I'm going to open up your microphone here. Can you hear me? Oh, sorry, go ahead one more time there. There you go.
Yeah, David.
Yes, great to have you joining us again. Yeah, I know I see here you had some questions about some of the technology here. Do you mind maybe repeating your question? Or if you had another question for our panelists?
Yeah, actually this is not a question, but this is an suggestion. On the presentation regarding about possibly showcasing vehicles. On the first presentation, I heard about some keywords like vehicles, reefer, container boxes. So my suggestion is to have that as well in the hub. But if space allows, it should be located outside. So my idea in commenting on this is customers. Possibly customers would like to or interested into adapting this technology could see the real vehicles and reefer with that technology that they can touch, they can see. So this will probably increase or encourage them to maybe to procure or to buy on this. Then on my second question, my second comment is, I heard about compact natural static storage. So I'm thinking about that during this time, pandemic, and maybe this technology will continue to be of use, especially in the e-commerce side, whose setup relies on a fulfillment or delivering orders on a short notice. Maybe this one, so they can expand their product offerings like catering to wet, maybe chilled items to be available to the customers on a short notice. So this is the essence of my comment on this presentation.
Yeah, perfect. Thank you very much, Federico. It's great to have that comment. You know, we're going to have some of these technologies, especially the ones that can't fit inside, like the reefer unit you saw earlier presented by Carrier. These will definitely be outside. So we will make sure to have these set up in a place where people can access it, as well as that idea of having it to be used in e-commerce and retail refrigeration as well. So yes, thank you very much for your comment. Also, I want to move to Mr. Kwang Guchu. I think you just sent us a comment here. I'm going to see if I can get you here on microphone. Mr. Kwang, can you hear us?
I think you can just ask the question.
Okay. Yeah. If you're not there, let me just phrase this question to our panelists. The question says, on the small horsepower CO2 condensing unit sold and installed in Japan for retailers, what is the noise level, and are they variable speed or capacity units? So I believe this is addressed to Gaku and Greg. Could you give us a little bit of information on the noise level and the variable speed capabilities?
Okay. The noise level over 2 horsepower is a 33 decibel A with a 10 meter distance. It is generally said very quiet. Our unit is originally designed for Japanese convenience stores. Japanese convenience stores are always located in the very city area. So we have to be install quiet product for neighbors. So.
Yeah, perfect. And yeah, so variable speed also. So these are also variable speed units as well. Is that right?
Yep. Yep.
Okay. Perfect. Okay, and you know, we're running out of time here. Let me see if I think Jan, go ahead.
I have one question for all the panelists. I would maybe ask for your brief answer. Let us dream a little bit. I would like to hear your opinion in terms of what is the next milestone for the CO2 transcritical refrigeration for next few years, horizon, let's say 2025. What is the next milestone? Are we talking about efficiency? Are we talking about cost? Are we talking about new applications? What do you see as the challenge of the industry over the next couple of years? Maybe we can start with Wyman, please.
I think the biggest, I think it depends. If we can break it up in, if we can break it up in sections, I think retail is going to be cost driven. I think volume is going to drive down cost, and it will increase the uptake of naturals. I think the next milestone for the industrial is in the industrial side of life. I think there's a lot of nice technologies coming up that's on the horizon, large capacity compressors, small capacity compressors, different ports. I think there's different technologies coming into the industrial solution, which I'm quite excited about for the future of CO2.
Excellent. Thank you very much. Maybe Christian, would you like to go next?
Yes, yeah, I support that viewpoint. Actually, I think we see the prices continue to get lower and lower, and the components are increasing in quality and efficiency. There's more component manufacturers on the market, so the industry is growing. And the number of installers that can handle the technology is also growing. So I think that all this is driving the price down, and we will have a sound competition also on the industrial applications, not only with the synthetic refrigerants, but also between the natural refrigerants, which is good because that will also drive the market in a direction of high quality and lower cost. So yeah, I don't think I have any further to contribute with here.
Thank you very much, Greg. and Gaku-san, please, your take on this point.
I support Christian's idea, yes, but the most important thing, maybe most effective one is, I think, a competition. There will be more and more manufacturers of CO2 condensing unit, and competition will reduce the price, market price.
Excellent, very good point. And Greg?
Yeah, I think just work, I think there's a broader to contribute to the food retail network right across installers, technicians, engineers to openly adapt to new technology. And I think this is one of the beauties of the innovation hub. I think one of the other key drivers is, we've got Glasgow coming up next week. More and more corporates are announcing their sustainability carbon emission targets. And I think a number of these broader objectives will continue to drive at least the discussion in some of the developing regions as to, the sustainability journey that they do take, and no better facility to enable that journey.
Excellent, thank you very much. It's reassuring to hear that we will see more competition. The availability of the components, while the uptake of these technologies will help also developing countries that don't have yet so much experience with CO2. So I think this is reassuring, even in the light of the project and when we are trying to achieve on the ground. Personally, I like to see more discussion about the sectors that have not yet been fully tackled with NATREFs. We have now a lot of discussion starting about the large capacity heat pumps with CO2, which is very exciting, as well as hopefully the integration of the air conditioning. So the next couple of years will be equally excited as the last few. And again, I'm glad that you guys are all joining the project, and we very much look forward to having your technology and expertise and yourself personally on the ground. Hopefully very, very soon next year, we will all meet there at the hub. And again, looking forward to working with you on these first installations, and looking forward to making a difference for this market, for this industry. So thank you again on behalf of the Cold Chain Innovation Hub project. All right, well, thank you for your time and your presentations, and we look forward to the next edition. Thank you to all our attendees for staying with us. We will be sharing the content with the website via our newsletter as well, so we will be spreading the word as we do. And again, thank you all for your attention and your time today.